All right, go ahead.
Hi, we're on the UCI Robofish project. My name is Osvaldo Montiel.
I am Katia Morales.
I'm Christian Hernandez.
This is the visual for our project. So what is the Robofish project? So typically it's a competition done in MA 165 and 265, which is the advanced manufacturing class. Students are walked through the process of designing and manufacturing a robot. They usually end up pretty similar, and it's a straightforward class. So we're participating in this competition as a design project. So some background, we've taken a few robotics and manufacturing classes, and we'd like to take, so we've built, as many of you, we built a quadcopter in 7A, 7B, we built a ground vehicle in 106. So we decided to take this project to challenge ourselves to design and build a water-based robot. So general goals and objectives. So the general goal is to design and manufacture a robot capable of traveling 12 feet underwater while being completely submerged. So in our main objective this quarter, so first is to complete all designs and modeling during the fall quarter. We also like to complete all the necessary calculations by the end of this quarter. And then next quarter, we'd like to begin manufacturing and have a completed robot by about mid-winter quarter. And then begin testing and do any necessary revisions and have that completed and have a fully functioning robot by the end of winter quarter. So we're taking this as a 2-quarter project. We've designated this quarter mainly to have all of our designs, planning, and calculations done, and hopefully be ready to do all necessary manufacturing next quarter.
Alright, so the requirements of this project, like we said before, is pretty much manufacture a sea creature. Most of the time from the class, it's usually a fish. This time we wanted to challenge ourselves by building a manta ray that is capable of traveling at least 12 feet underwater. The sea creature must remain completely submerged without sinking to the floor. This is going to be like one of the biggest challenges for a project because one, you have to make it so it's not heavy enough so it can sink down to the floor, but also not light enough so that it will submerge to the top. So we kind of need to find kind of like that midpoint level. And also it must be waterproof. This is also going to be like one of the biggest challenges because, you know, as crazy as it sounds, I mean, your sea creature needs to be waterproof. All the electronics, no water can seep through. No water can, you know, pretty much ruin the electronics. As soon as it goes inside, it gets to the electronics, your project or your fish, or manta ray in this case, is pretty much done for. So we need to find a way exactly how to seal, you know, everything, how to make our robot waterproof, so that, you know, it can complete, you know, these requirements. And also, it must mimic the motion of an actual manta ray, meaning that, you know, for a manta ray, you know, its main source of propulsion is usually on the wings. There's no way that's propelling itself to the back, so we need to also keep that in mind. And it also needs to be large enough to accommodate all necessary electronics within the manta ray. Alright, so this is our timeline. So the gist is that the first quarter is just mainly dealing with research, planning, designing, modeling, and all buoyancy calculations. All of second quarter, starting from week 1, just begin manufacturing. As soon as we reach the midpoint, which is around week 5, that's when we're going to be testing. And then so that way we can see, you know, does anything need to be improved? You know, does it actually reach that 12 feet mark? And also, you know, if there's any weight changes that need to be made. Yeah. So that's our timeline, and we're expecting for all of our modeling to be done around this week. Alright, so a little quick tour of our progress. So our research has been completed, all planning design has been completed. You know, we already know the dimensions of our manta ray. We already know, you know, how tall we want it to be, how wide we want it to be. The chassis, we already know like how thick. The walls, how thick as well. And right now we're still currently modeling all the main components, and you know, as we go along, you know, within the weeks of this quarter, we're still going to keep updating our 3D model just so that, like, you know, when we assemble it during SolidWorks, it all fits together, it all works out together. And also, we want to put together, you know, a final parts list of everything that needs to be ordered by the end of the quarter, so that way when we come back for winter quarter, you know, we just go straight ahead into manufacturing. so that way we can start testing as soon as possible. And then this is just some of the things that we wanted. That's like the chassis, this is the wings, and then for this is going to be like an arm mechanism. That's pretty much where our flapping is going to be. It's going to be done through a servo, which will go on much later once we get into our budget.
Hi, so I'm Katia. For the budget, we do have $300 for this project. It is $100 per person. We are a 3-person team. And everything has an approximate next to it, since we have decided a little what we're going to use, but not the specifics. Once we finish that part list that he mentioned earlier, we will have the exact amount. We do still have to pick specific materials for the 3D design, for the CNC, and which specific silicone, which we will decide on once we do all the calculations, which will be taking place within the next few weeks. For resources, like I mentioned, we are a 3-person team. We are all taking this for a 2-unit course. Our advisor is Professor Madhu. We haven't really talked to him much. The person who we do go to if we have any questions and who we meet with every week is I'm not really sure how you say his name. We do see him every week, and we do have a 2nd-year volunteer student right there. He wanted to volunteer for our group since he is currently undeclared, undecided, and he wants to see if this is the way he wants to go with his degree. For subsystems, Osvaldo is in charge of doing the research, design, modeling for the main body part. Christian is in charge of doing the wings, and I'm going to be in charge of doing the support arm. We didn't assign any specific tasks for our volunteers since he hasn't been very active, and we didn't want to assign a major role to him and then have him not show up and push back everything for us. Therefore, he will be assisting us once we start manufacturing, but no main roles will be given to him. If you guys have any questions,